For Charles's law problems, we're going to do essentially the same thing we did for Boyle's law, except we're, applying it to a different formula. The steps, however, are still essentially the same. The best thing to do is to start out with what you are given, write out a list, and then plug that into your equation. So in problem number 1, we have a sample of nitrogen occupying a volume of 250 milliliters at 25 degrees Celsius. What volume will it occupy at 95 degrees Celsius? So we're just going to start out from the top. Our first initial volume, our V1, is 250 milliliters. And our temperature at that volume, they tell us, is 25 degrees Celsius. But here's the catch. You have to be very careful because any of these gas laws require the temperature to be in Kelvin. So we can't just use 25 degrees. What we have to do is take our 25 degrees Celsius and convert that to Kelvin. And they give you, very nicely of them, to give you the conversion for Kelvin to Celsius here, or Celsius to Kelvin. To get Kelvin, we just simply take our temperature in Celsius and add 273. So that would be 273 plus 25 gives us our temperature in Kelvin, which is 298. Okay, that's the one thing that you can't forget to do on these problems. Now, moving on, what volume will the gas occupy at 95 degrees C? So we don't know our final volume, that's what we're trying to find, but we do know our final temperature is 95 degrees C, so again, not just writing what we're given, we have to convert that to Kelvin, so 273 plus 95 gives us our new temperature in Kelvin, which is 368 K. And now we're ready to plug into our equation. So the equation for Charles's law is V1 over T1 is equal to V2 over T2. Okay. So now we just do the same thing. We're going to plug in our variables. Our V1 was 250 milliliters. Our T1 was 298 K. And we're going to set that equal to our V2 over T2. V2 we do not know, so we're just going to leave it written as V2. And our T2 is 368 K. So we want to solve for V2. In order to get V2 by itself, we need to do the reverse operation of what is currently there. So right now what's currently there is division. So instead we're going to multiply by 368K. That's going to cause those to cancel out, leaving us just with V2, which is what we want. Whatever we do to one side of the equation, we must do to the other. So we multiply this side by 368K. Now if you notice, this awesome thing happens. Our degrees Kelvin cancel out, which will be perfect because our units that will be left will just be milliliters, which makes sense since we're solving for volume. Okay, so final step is just to take your calculator and figure out what the answer is. We have 368 times 250 divided by 298. Punch that into your calculator and you should end up with, rounding to a whole number, 309 milliliters. So on your answer line, V2 is equal to 309 and 9, and don't forget your units. Again, if you expect to get full credit for these problems, you must make your list, show your work with the units, show your units cancel, and then make sure you have on your answer line the final answer with the units included.